Yes. So yesterday we were handling this particular. Okay. So we were through with this theory. I hope you have no questions on this theory. Hello.
Yes, sir.
I hope you have no questions on this theory.
Understood.
Okay. If you have any, you can ask it. This activity of the sample is modulus of the rate of nuclear decay per time. You will see that this will be useful. Modulus dn by dt is lambda n. Remember that.
Tell what is the neutrino and antineutrino?
See, antineutrino and neutrino are particles similar to photons that are released in certain reactions. That's all. It is just released.
Another thing. Then the radioactivity is when proton gets converted to neutron and neutron gets converted to proton. Practically, sir, when they get released, sir, then the compound won't have to get things done.
Compound?
Like atoms.
So what are you talking now? You imagine a nucleus. In that nucleus, there is a proton which has got converted to neutron. And yes, it has released one electron and one neutrino.
Yes.
What is the problem?
One electron will also be released.
Yeah, one electron is released. I told you.
So his doubt is that the atom should get charged.
Okay. Atom will not get charged. Atom will change. See here you see uranium will get converted to bismuth. Bismuth will get converted to something, thorium, things like that, and then finally, it will get converted to Pb. Yes, it's happening. The atom itself is changing. The characteristic itself is changing. Correct. See, you can see theoretically, you can prepare gold from lead. Is it clear? You can get gold from lead. Hello, are you with me?
Yes, sir.
So you can do it. But only thing is, the amount of money that you are going to spend to convert lead to gold will be several times of that gold. So therefore, you will not do that. Okay, is it clear, Mr. Adil?
Yes, sir.
So specific activity, the rate per unit mass. Okay, so this also I have discussed yesterday. And I think we were dealing with this problem yesterday. Hello.
Yes, sir.
Yes, sir.
Now, is this problem clear to everyone, or shall we redo this problem?
Yes, sir.
I'm not getting any answer from you.
Yes, sir, does. Yes.
Abhinav?
Sir, I have a doubt. But
You ask now, I have a doubt. See, you are a different person. When I am myself asking, any student has a doubt here, shall we redo it? You should say, yes sir, I have doubt, you please redo it. I am giving you an option, no?
yes, sir.
ಎಲ್ಲೇ ಮಾತಾಡ್ಬೇಕಲ್ಲಿ ಮಾತಾಡಂಗಿಲ್ಲ ಎಲ್ಲಿ ಮಾತಾಡ್ಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಮಾತಾಡಬೇಕು ಇಲ್ಲಿ ನಾನು ಪಾಸ್ ಮಾಡಿ ಕೇಳಿಕತ್ತೀನಿ anyways, if all of you have understood it, fine. Otherwise, just see this. In delta t time, okay, in delta t time, delta n decays and n into delta t enters the system. Is that first statement understood by everybody?
Yes, sir.
Yes, sir.
Abhinav?
Yes, sir. Understood.
Now, I will divide this delta n plus delta nt divided by delta t, and I will take limit under as delta t tends to 0. Then I will get minus dn by dt plus n is equal to lambda n. So, if you take that n that side and multiply through it by minus, then you will get dn by dt is equal to n minus lambda n. Okay?
Okay, sir.
I hope now it is clear.
Yes, sir. Understood.
Right. And there afterwards, so we get here dn by dt is equal to n lambda n, and what follows is this. N is equal to n by lambda, so and so. Right?
Okay, sir.
So that's the way to split the problem logically and handle it.
Okay, sir.
Now this one. A nuclide, aram se apply the basics, then this will be very simple. A radioactive nuclide can decay simultaneously by two different processes which have individual decay constants lambda 1 and lambda 2. Understood? It can decay by two different methods and individually it will have lambda 1 and lambda 2. The effective decay constant of the nuclide is given by lambda is equal to. Apply the basics and get the answer.
I used equation which you wrote on the first slide, it was 3.
Okay. So he is firm because in chemistry also you have these two parallel reactions and they are happening like that. Right. Anyway, I have given you time to discuss that. The answer is D is right. Okay. Because these two are parallel reactions that are happening. So this will decay and give you N1 and that will decay and give you N2. See here that you have to see here is that, see this equation, you please understand this very carefully. dN by dt, what is this? This is the rate at which the decay is taking place. This itself is proportional to at that instant of time. Okay, see the rate at which it is decaying at some instant of time is itself proportional to what are the decayable content, decayable radioactive constituents that are present at that time. That is the crux of all these things. That is the crux of all these things. Okay? So yes, this is decaying, and therefore this is decaying with the decay constant lambda n. Hello, clear?
Yes.
Now here there are two things that are happening. One is decaying with one parallel, one reaction is happening like this, and the other reaction is happening with the lambda 1 and lambda 2. Two reactions. But what is important is even though those two reactions are happening simultaneously, see it is not that those two reactions are happening simultaneously, that itself is dependent upon n. Okay, that means now, see, even though there are two reactions that are taking place, this reaction is taking place, see, at a given instant of time, there were n nucleides which are about to decay. So one is decaying with this, one reaction is happening place at this rate, another reaction is happening at this rate. Okay. Now both these reactions depend upon this n only. Hello, are you with me?
Yes, sir.
It is not bifurcating. See,
Yes.
it is by chance. This is decaying with lambda 1, this is decaying with lambda 2. So both of them are decaying based on this. Okay. So therefore here dN1 by dt, okay, will be equal to lambda 1 n, and dN2 by dt will be equal to minus lambda 2 n, and dN by dt, which is addition of these two, is itself equal to minus lambda. See, that is this the reactants are there, n reactants are there. It is some, it will decide, okay, I will decay by lambda 1. Another will say I will decay by lambda 2. So that is happening simultaneously. So the rate of decay, whether through lambda 1 or through lambda 2, is dependent upon how much radioactive constituents are there. Hello, is it clear? See, initially what I gave you there, what logic we followed there, that is there is n, and some n1 will decay with lambda 1, n2 will decay with lambda 2, will not hold good.
Yes.
Understood? It will only depend upon the total constituents of the decay that is present at a given instant of time.
Yes.
Understood? Hello?
Yes.
So therefore you will get lambda is equal to lambda 1 plus lambda 2. Okay. See, these are the issues with respect to this, because the most important thing is this number, this decay what we are telling here will depend upon how many constituents are there. See, you now visualize the reaction. Two reactions are taking place. So you can now see many molecules, many nucleides. So suddenly you see at a given instant of time, this nucleide is decaying at lambda 1, and this nucleide of the same thing one is decaying with lambda 2. But both these decay processes are dependent upon the total number of nucleides that are present at that instant of time. Understand? So they will not decide upon which one is going to decay with lambda 1 and which two is going to decay with lambda 2. Did you get that logic, students?
Yes, sir.
Okay, fine.